Hello and welcome to the video. In this video it's going to be a setup of this thing here, the A3Super3 from HobbyEagle. Now this is a fixed wing stabilizer and is the most sophisticated of the ones that we've had a look at. For those of you that have been watching the channel for a while, you'll have seen the other two in the family. There is this one here which is the A3L V2, which is a very basic one, and I cover all of the setup of this. This will only really do very basic stabilization, it just kind of counteracts kind of wind and gusts. And then we had its bigger brother, which was the A3 Pro, which has pretty much all the same functionality as its bigger brother, and things like trainer mode, but again it was all set up through button presses and the LEDs. This one is a little bit different. So while I unpack this, let me kind of go through what the differences actually are. It's all the same kind of flight mode, so attitude, lock, hover, trainer mode, and all of that goodness. It is firmware upgradable, because you'll have noticed that there aren't any buttons or LEDs as such on this, and also the outputs are very different too. If you compare the outputs with the A3L V2, you can see that there was only really 3 outputs on this, and everything else was dedicated to the inputs from the radio receiver that you had. With this thing, it's an awful lot more compact, and the majority of the pins that's on here is decided for the outputs. Now it is firmware upgradable via the USB, and that is the big difference. You're going to need a PC and a little application in order to set this up. There is also a Wi-Fi dongle, and I think there's an Android app for it as well as a kind of programming card that you can plug this into if you want to do that as well. Inside the box along with it, you get the big capacitor that you can install to make sure there aren't any voltage sags. You get a load of cables to plug it into your receiver, some mounting pads for both the actual stabilizer itself and this little auxiliary piece here, which is the status LED, which shows you the mode that it's in, and also is the place where you can plug it in. And that's quite a nice touch. You can bury this in the middle of your model and you can have the LED somewhere where you can get to it or see it and plug the USB cable in if you want to change how it's working. So to power this, before we're going to put it in the fixed wing, we're going to have to connect this up. Now, I'll just connect it up at the moment to an X8R, but we could use a very simple little receiver because it's all S-Bus. So I'm going to plug in the S-Bus out into the S-Bus in, which is the 3rd set of pins in here. There we go. And I'm going to have to power it before I plug it into the computer from a battery eliminator circuit, because the USB connection, as you'll see in a second, it doesn't power this. But if I plug this in, there we are. It is complaining at the moment because my radio wasn't turned on. Let me just show you very quickly how I've got the radio selected. So let me just turn the radio on. You should see that the red light stops flashing. It's gone solid, and I can actually, by flicking the switch on the radio, I can actually change the modes. And hopefully you can see that on the video. It's kind of changing different colours. Okay. So now we've got all that done, let me just very quickly show you how the radio is set up. So the way you want it done is, I would suggest having the outputs like this. So aileron, elevator, throttle and rudder, those are the main controls, and then have an extra couple of controls. One for mode. You can either have 3 or 6 positions, again we'll look at that in a minute. A rotary control for the remote gain, and you can also have the next 2 channels as auxiliary things, because the really cool thing with this particular stabilizer is, because it's got 5 outputs, if you're only using 2 or 3 of those to control surfaces on your model, then you can use outputs 4 and 5 to present some of the channels. So you could use them for gear, flaps, pan and tilt servos or whatever. So there are 2 bits of technology you need to download onto the PC before you plug it in. They are available from the website. I'll put a link here in the description. You need to download 2 of them. One is the firmware updater, and the firmware updater, I would recommend plugging it in and going through the process. I updated this very quickly when I first got it. It's dead easy to do. All you just do is go onto the application, select that it's an A3 Super 3, plug it in, click upgrade, and it just kind of does it all itself. And the second thing you need to download and install is the actual A3 configuration software itself. So I've downloaded both of those. Let me start the A3 configuration software and plug this in. My tip here would be make sure that you've plugged this in first before you start the configuration software. It seems to work better that way, and find the COM port. So here we are on the computer. We have everything plugged in. So we've just plugged in the cable into the computer, and I've also powered the X8R with a battery eliminator circuit. The receiver isn't powered by the USB connection, so you are going to have that plugged into some power to do this setup on the bench. Now, because we are connected, so you can see here it says COM8 connected. When you first plug it in, it should automatically find the drivers. Although, as I've already said, you can download the drivers and install them before you get into this. We can see here that we've got lots of green lights, gains set up. So what we're going to do first of all is read the settings. So we can see the firmware version on here, and again I'd recommend updating it if you possibly can. And we can now look at the different pieces in here, and going through is how we set it up. And again, on the other videos that we've had a look at, the other pieces, the way you do it is by pressing a button and looking at LED lights. So this is an awful lot nicer. So if I move the radio about, we can see it all moving, so that's good. So let's just go through it piece by piece. First of all, we can decide on the stabilizer whether we want a 3-position mode, which is what I've got it set to now. So as I flick the mode switch, it looks like that. And we can decide for each position what we want. So again, we have gyro off, normal mode, which is the gyro will get rid of uncommanded movement in the sky, kind of take account of wind and gusts. We have attitude lock trainer mode, which also levels and also limits the maximum pitch and roll as well. That's great for very relaxing FPV. Auto level, which is like a oh dear switch. Auto hover, and a user defined setting, which you can just decide which is which. Now I normally would set up for a first flight position 1 as normal, position 2 as something like attitude lock. I will actually put it, tell you what, we'll do normal as gyro off for the test, and then we'll have it in normal and trainer mode. So let's write that to the thing. There we go. I would always just read it back, double check that it's saved it. Great. So now the 3 positions, you can kind of see here at the bottom, are going to be off, which will allow us to get the plane into the air. That's always important for the first flight, so that we, if we do go into one of these other modes and we've made a mistake, we can come back. Last couple of things on this screen. The user-defined mode that I talked about, which is the bottom, you can decide whether or not the aileron, elevator, rudder, how that all works. And you've also got the maximum tilt in trainer mode, which is the number of degrees. I would leave it at 60, but actually I like something like 70. I like it to be slightly more aggressive. Okay, that's all done. Again, remember to save anything you change before you come off the screen, otherwise it won't be saved. In the next screen, we can decide the kind of craft that we want and how we want it all connected, whether or not we've got a flying wing, whether or not we have 2 different aileron connections, if we're not using a Y cable with a standard kind of rudder, but then with 2 elevators, or for a very simple plane, it has a Y cable, then it's going to be connected to out 1. If it's a single elevator controlling the entire elevator on the horizontal stabilizer, that's going to plug into out 2, and then the rudder will plug into out 3. Now the really cool thing is, as we've already mentioned, aileron 2 and elevator 2, if they're not being used for something like this, so if we look at a very complicated one, like this for example, you can see that the out 5 is being used for this second elevator control. So, but if you've got a relatively basic one like a flying wing, then aileron 2 and elevator 2 outputs actually on the stabilizer are available to do pass-through, which is quite clever. So we're going to set it for the plane that we're interested in. So let's write that. There we go. Read it back, make sure we're happy. Awesome. Mount orientation is next. How do we actually want to put it in the model? We have 4 options depending on the standard setup. I am going to put it in the standard way, so I'm not going to change that. That works for me. Always make sure that the front of the gyro is always heading or pointing towards the nose of the plane. That's the only thing you have to be careful of. Apart from that, you can put it any other way. Gyro and gain, I wouldn't look at anything like this. We're going to come back in a little while to look at potentially, this is where we're going to reverse the aileron, elevator and rudder if we find that the controls on the model are the wrong way round. So we can actually come in here and change these later on, but for now we'll just leave them as they are. The next one is the radio. Now if I move the controls on the radio, we need to kind of match it. So if I move the aileron on the radio, the aileron is moving the right way on the screen. Now by default it's set to standard. Now we're using S-Bus, so I've selected S-Bus up here and everything started to work. We can also make sure that using the trims that they're in the neutral position, so these all settle at 0. So the aileron is on channel 1, elevator is on channel 2, which is right, rudder is on channel 3, which is great, and that's because that order that we've already set up is kind of working. A2 and E2, now these are the two that at the moment we're going to have pass through onto the model, so we could use them for gear or flaps or a pan tilt servo for FPV. It's one of the really cool things about this. So we are going to change those. If I move the gain knob, at the moment it's thinking that's A2, so I'm going to change the gain. So that's channel 6, so let's change this one to be channel 6 and say right. Okay, and now we can see the gain at the bottom changing as we move it. That's fab. And then if I change the mode switch, the mode switch is right. So in that case, we're A2, that needs to be channel 7, that needs to be channel 8, I think. And that's because channel 7 and 8 are actually set up for other controls, and they will now be passed out to the to those two outputs, A2 and E2, because we're not using them in the stabilizer. We can now connect them to anything, and that's really cool because we don't have to use a big receiver. We can use a very small S-Bus receiver with only one S-Bus out, and we've got those additional two controls, and that could be maybe controlling the gear, maybe flaps, or like I said, for me, something like a pan and tilt servo arrangement would be great. Speaking of servos, that's the next one that we need to set up. At the moment, if I just move the aileron left and right, you can see because the wing type, the aileron is supposed to connect to output 1, we can see that that's moving okay. In here we can change the sub trim, the limits, and also go through the travel limiting and servo trimming process using the radio. Personally, I still use the throws and stuff and set that all within the radio, and that also allows me to do things like dual rates and that kind of goodness as well, and adding expo on the controls as you normally would. If I move the elevator, output 2 should change, which it does, and again that's because output 2 is here, which means that if I move the rudder, it should be output 3 that moves. So if I move the rudder left and right, there it is, fab. Now because we've mapped in the radio A2 and E2, which aren't doing anything, to channels 7 and 8, if I go into servo, we should see those outputs working too. Perfect. Let's write that stuff. We're happy with all that. Last few things we need to do in here before we can install it into the plane. These are all the sensors and how they're working. So if I kind of move it around, you can see all the accelerometers and gyros moving. We will need to come back in here for level calibration. That is one of the last jobs we need to do once it's inside the plane. If I click on level calibration, actually tell you that put the plane slightly nose up, and that's exactly what we need to do. So now we've got all that done, let's just write all that stuff back. So now we've got the flight mode set for the 3 position. We could have a 6 position switch, but that's not the way it's set in here. And again, don't forget, if you change anything, make sure that you write it down and then you'll see the changes. Wing type we've got set, so we know how everything's going to be plugged in. We have this little diagram. The mount orientation set, we're not worried about that for now. We'll come back and do the reversing when it's inside the model. We know the radio's all mapped. We know the servos outputs all set, and we're ready to do level calibration when we come back. There's some stuff in advanced, but to be honest, unless you really need to, I wouldn't come in here anyway. So let's go to the bench and actually plug this thing in. So now that's all set up on the computer, we need to install it into the plane. Now I would always recommend, just as with the other stabilizers, well, any stabilizer or flight controller in fact, make sure you've flown it in manual mode without anything installed, so you know where all the control surfaces need to be for straight and level flight, and make sure that you're happy with the central gravity. When you're going to install this into the plane, just unplug all of the cables from the receiver apart from the throttle and plug them into the outputs. Now again, we're going to plug the aileron into output 1, elevator into output 2 and rudder into output 3 on this stabilizer, because that's what we were told in the little setup program that we've just looked in. Now I suppose you could also forward some of those auxiliary channels and actually forward the throttle using one of the spare channels, so you could use a really small receiver, something that you'd use in something like a multi-rotor. But personally, the fact that the manufacturer hasn't talked about that in the manual means that that's probably not something I would do. I'd still install your throttle into the receiver, so it's just the control surfaces that have been handled by the stabilizer itself. Once the stabilizer is installed, then I would power it up, and normally again I power it up just with the battery eliminator circuit to power the servos, just because until I'm happy that everything's working, I don't want accidentally to start the motor, and then it's a case of moving all the controls to make sure they're moving in the right direction. Now some of the controls on this radio are backwards, and that's absolutely fine. Just need to go into the radio itself and reverse whichever channels are wrong. On mine it's actually the aileron. Once I've reversed that channel, then everything's working okay. Again, and I personally would then set things like the throws, the rates, and also the expo for each of the controls on the radio while I was doing this step as well. Now we've got that set up, then we also need to check the direction of the individual movements too. So what we need to do is pop it into something like stabilize mode or something like trainer, and we need to turn the gain up all the way on the radio and then rock the plane from side to side, front to back, and we're looking for the correction. Now it's very clear in the manual the way it works, and what you're looking for is for the control surface to move to counteract that uncommanded movement. So in the wing that's rising, the aileron should rise, similar with the rudder and the elevator. So go through and triple check all those. Unfortunately, my aileron was backwards, the other two controls were fine. So now I need to reconnect to the application, go into the gyro and gain screen, and I need to click on the reverse button just for that particular control, which is the aileron. Click on right in the application, and then you'll hear everything just flick, and then make sure everything is moving. So now we know that the control surfaces are moving okay in manual mode, and they're correcting the right way round as well. This is the most common mistake that people make with stabilizers, is not checking that the movement is in the right direction. So triple check it, and that also is why we need a manual mode. So when we fly, if we do put it into one of the stabilized modes and it immediately starts to lose the plot, then we can just take it out. It usually means that one of the corrections is the wrong way round. Now we've done that, we can then trim all the control surfaces using the application as well. Go into the servo tab, and then you can either go through the servo trimming or travel limiting process, or I just use the little controls on the screen just to change the number and write it back to the model, and just keep going around for the rudder, elevator and aileron until they're back in the positions they need to be for straight and level flight. And we know that, of course, because we did that before we installed the gyro. At this point we are getting very close. Last couple of things that we need to do. We need to go into the sensor screen, make sure that the nose is slightly elevated, and then we need to click in the bottom right hand corner, level calibration. It'll come up and warn us that we need the nose slightly elevated, as we saw before. Just click OK. The whole thing will flash blue for a couple of seconds. Don't move anything. When it's completed, it'll tell you on the screen, and that level calibration is done. Now that that is done, then that is all the main setup. I'll very quickly install just a pan and tilt setup here, a pan servo into outputs 4 and 5, and you can see here now, because we forwarded on those 2 extra channels onto those spare outputs, we can control other things with it as well. Really nice feature in this stabilizer, and one that could come in very handy for planes with extra pieces on. So now the plane is all set up, then it's just a case of getting out there and giving it its test flight. Go to the field, launch it and fly it in manual mode first. Make sure that everything is responding and working well. Once you're happy with manual mode, then flick it into the stabilize or normal mode and just make sure that it's still okay. Be prepared to immediately flick back into normal mode if there's anything weird going on. Anything weird is probably because you've got the gain too high on the radio. If you start seeing oscillation in any orientation, or if it starts to flip, roll or dive, then it's probably that you've got the correction for that particular control the wrong way. Pop it back into manual, recover the craft and bring it into land and change that on the PC. So my tips for a successful installation with this, along with any of the other stabilizers, are the following. First of all, do test fly and trim the plane before installation. Doing that means that you're not trying to troubleshoot any plane setup issues as well as the stabilizer, and you know where all the control surfaces need to be for straight and level flight, and you can reset that in the servo tab when you're setting it up on the PC. Do set up the model type, modes, servo frequency, receiver type and all that stuff that we did in the video before you plug it into the model. It can be a lot less confusing just doing it like that before you have all the wires and everything moving around and servos twitching and potentially motors starting and things like that on the bench. Do again triple check you've got the gyro correction the right way. It is the most common mistake to do. Make sure that the gain's very high, make sure you're in one of the stabilized modes and test it on the bench. If you're not sure, refer to the manual. The graphic is very clear on how it's supposed to be. Make sure you got manual modes as one of the modes for the initial flight, so that if you have made a mistake, and it's easier to do than you think, then you have a fallback position. You can immediately turn the gyro off and then land the model safely. Don't forget to check the gain settings on the radio before every flight. You can actually set it so that it will warn you if the pot has moved from where it was at the end of the last flight with that model, because changing the gain can be very handy on the radio. If you're flying in windier conditions than normal, you can just turn it up or down a little bit, just less than when it starts to induce oscillation. Don't forget to allow for a nose-up attitude, a slight nose-up attitude when you're calibrating level. If in the test flight, when you put it into stabilize or something like trainer mode, where it's going to maintain the pitch angle, if it's sinking or rising, then you may need to go back to the bench and redo that with a more or less nose angle to take that into account. Don't forget, when you plug the model in, leave it until all the control surfaces waggle and don't move it at all. Let it initialize and calibrate properly. If you do move it and try and fly it, you might find that it misbehaves a little bit. If that's the case, bring it back, unplug it, count to 10, plug it back in and just leave it until all the control surfaces waggle to let you know it's ready to fly. And the last thing is, think about the fail-safe position you want on the model, because if you accidentally got this wrong and you had it on something like trainer mode where it will auto level and you had the fail-safe as the throttle at 50%, this thing will fly until the battery gives out. So do think about what you want. I would normally put it into manual mode and put all the control surfaces at neutral position and throttle off, but it's very much your own choice, and think about it before you have a fail-safe problem. So hopefully that's interesting for those of you that are interested in setting up the stabilizer. There is a little bit more to it with using the PC application, but if you don't like the idea of playing with LEDs and buttons, it's a great choice. But it does mean that if you want to change anything at the field, you've got to have some kind of computer device or that little programming card in order to make changes. Thanks for watching the video and watching right to the very end. You can find me in all the usual places on social media, and if you like the video and like what I'm doing here, then hit the subscribe button and hit the bell notification icon too. If you really like what I'm doing, you can go the extra mile and become one of my Patreons for access to me directly for support, and also giveaways and regular updates too. If you're looking for particular content, then check out the playlist. I organise all of my videos into playlists, so if you're looking for a particular topic, you can find everything here. If it's called Introduction To, it's designed to start very simply and build on that simple introduction to teach you all about it. If it's called For Beginners, then that is really aimed at people who are brand new to that part of the hobby. You can also search on YouTube for anything that you're interested in using the search function at the top. So iNav Painless 360 will find all of my videos and even the playlist around iNav. So thanks again for watching and happy flying.